Physics lesson by Brooke and Gigi.
Hi, I'm Gigi.
I am Brooke, and we are going to explain the physics of otters with this lovely problem. So our example problem is a 7.5 kilogram otter slides down a hill starting from rest at the top, and the sloping surface of the hill is 8.8 meters, and the top is 6.5 meters above the base. If the speed of the otter at the bottom of the hill is 9.2 meters per second, how much energy was lost to non-conservative forces on the hill?
Okay, so for this problem, you have to know a few things. First, you have to know the difference between potential energy and kinetic energy. So, potential energy is the energy of position. Or in other words, at the top of the hill, our otter has potential energy before it's moving. Kinetic energy is the energy of motion. So as it starts moving, the potential energy gets changed into kinetic energy. So our formulas for potential energy and kinetic energy are potential energy, U equals the mass times gravity times the height, which we have here. And the formula for kinetic energy is 1/2 the mass times the velocity squared. And in this problem, we have to use the change in velocity because we're given a final velocity and an initial velocity. And as we said before, since energy is being transferred from potential energy to kinetic energy, we need to find the difference in the potential energy and the kinetic energy to find the total change in energy during this process.
So that was a lot of information, but here is a handy dandy list to break it down. So we have gravity, which equals 9.8 meters per second squared, mass of the otter, which is given in the equation at 7.5 kilograms, the height, which was also given, 6.5 meters, the change in position of the otter from the top to the bottom of the hill is 8.8 meters. We have initial velocity of 0 meters per second because he wasn't moving at the top, and given is the final velocity at 9.2 meters per second. We're going to use the kinetic and potential energy equations as Gigi has given us, which is K equals 1/2 mv squared. The potential energy equation where UG equals mgh, and then the change in the energies at delta E equals potential minus kinetic to find the amount of energy lost.
So we have our equation for kinetic energy. So we plug in our values, so we know that our final velocity is 9.2 meters per second, and our initial velocity, since the otter wasn't moving, is 0 meters per second. We also know that the otter weighs 7.5 kilograms. So plug in all these numbers, 1/2 times 7.5 kilograms times the total change in the velocity is equal to 317.4, and our units are in kilograms, kilogram meters squared per second squared. So now we have to find the potential energy. So we know that the otter is 7.5 kilograms. We know that gravity is 9.8 meters per second squared. And we know that from our picture that the total height at the beginning is actually 6.5 meters per second. That's good. Okay, so the potential energy is equal to 477.75, and that's also in kilograms meters squared per second squared. So we were asked about how much energy was lost during the sliding down of this otter, right? So we have to subtract the potential energy, the kinetic energy from the potential energy. So we plug in our values, we got over here, and our total energy change is negative 163.35, and that's in kilograms times meters squared over second squared.
And yeah,